Hello everybody, my name is Amy Bear. I am here to present a longitudinal view of gender balance in a large computer science program. The study was conducted at the University of Michigan along with my collaborator Andrew Diorio. As you may know, we've had huge growth in the computing field over the past 10 years, and this is no different at the University of Michigan. Here's a graph of graduating computing majors at the University of Michigan over time. We've also seen tremendous growth in the number of women in the program. We started with 14 women in 2008 academic year to 171 women in the 2018 academic year. While this is really great, we still have a long ways to go. The overall gender balance in the university is around 50-50, but in computer science, it's still only 27.5% women. However, we also noticed that in one of our CS1 courses, there was 42% women. And this says non-engineering here because we offer CS through both the Arts and Sciences School and the College of Engineering School. So this is the Arts and Sciences CS1, which had 42% women in winter 2018. And this is great compared to that 27.5% number, but we're wondering how that changes over the course of our curriculum. And we saw that once we got to the upper level courses, there are only about 20% women. So we started to ask, why exactly are women leaving? So we found other works that focused on this exactly, and we saw that indeed women are twice as likely to consider leaving a CS major as compared to men, and even if they get all the way through the program and graduate with a computing degree, they're less likely to take a job in industry or in academia. These studies ask questions like, why do women and other minorities leave? And they found that maybe women and other minorities feel out of place or they lack self-confidence, and that's why they ended up leaving CS or computing. Equally as an important question is, why are women and other minorities staying? And we found that there was a variety of potential reasons for these, such as same-gender student interaction, pace and workload of classes, prior experience, and faculty encouragement, among many other things. While all this qualitative data is very important and very valuable, we realized that we don't even know where to start in our program to look at these or apply this qualitative data. So we started to ask some more quantitatively based questions so that we can pinpoint areas that need the most focus, and so we can find where we can most affect change in our computer science program. The questions that we started out with were, where in the computer science curriculum does the gender balance change? We saw at the start that we had 42% women. By the end, there was only 20% women. So where exactly is this changing? And are grades playing a role in this change? Before we jump into the results of our study, I just want to give some background information. Michigan offers CS through both the Engineering School and the Arts and Sciences School, like I said earlier. Just to detail this, the only difference between the two programs are non-CS courses and what CS1 course is taken. There are two CS1 courses, one offered through the Arts and Sciences School and one offered through Engineering School, although they teach the same principles. After that, the entire program is the same, other than the non-CS courses. For our data set, we started out with over 30,000 records, and this was 10 years of data, from the fall 2008 semester to the fall 2018 semester. This was great to work with all this data, and we started using all of this data when we were generating graphs and looking at different analysis. But we realized that because we've had so much growth over the past 10 years, maybe these results weren't as reflective of what our program looks like today. So we decided to cut down our data set by 5 years to still over 20,000 records, but now we feel that the information we're about to present you is more accurate of what our program looks like now. So now we can jump into the results, and we'll start out with looking at failure rates and withdrawal rates, and then we'll move to attrition rates and what happens to affect these attrition rates, and then we'll wrap it all up, talk about what we concluded from the study and what we can do in the future. So our first question, as we might ask, if we're asking how does the gender balance change, is are women failing out of the program? And the straightforward answer is that no, they're not failing out in the program. We see in this graph here the CS3 failure rate. On the y-axis, we have percent failed by gender group, split between men and women. And on the x-axis, we have the time over semester. We see that there's no significant difference between the men and the women's failure rates in CS3. We also see that women are actually failing less in 3 courses: non-engineering CS1, CS2, and in upper level courses. So we can pretty definitively say that women are not failing out of the program. The next question we asked is, are women withdrawing? Because if they're not failing, we want to ask if they're voluntarily leaving the program. This table shows a chi-squared test whose independent variable was gender and the dependent variable was withdrawal rate. We can see that in non-engineering CS1, CS2, and CS3, women are withdrawing more than men. However, I want you to notice that the difference in means here is at most 2.2%. This will come back up later, so I just want you to note that for now. So just for a quick review of failure rate, we found no evidence that women are failing out of the CS sequence. We also found that in 2 classes, in CS2 and non-engineering CS1, men are failing more, but women are withdrawing more. This is interesting because we think that this might be indicative of a different reaction to poor performance between the genders. Perhaps women are prematurely withdrawing when they might have passed the course in the end, and men are not withdrawing when they're in danger of failing, resulting in more men failing and more women withdrawing. We saw that in 3 courses, women are withdrawing at a higher rate than men. And while we think that this could partially explain the change in gender balance from the beginning of our program to the end of our program, we don't think this is a large contributor. And the reasoning for this is because, remember I told you to remember that 2.2% number, we don't think that that magnitude is very great, especially when we compare it to other things that we looked at. And this difference also only exists in about half the courses in the sequence, and not all of them. So we think that withdrawal rate could have an effect on the overall change in gender balance, but we don't think it's the silver bullet here. The next question that we asked is, so women aren't failing and they're withdrawing, but not at super high rates. So we want to ask is, are women passing classes and then just choosing not to continue in the sequence? So here is a graph of a non-engineering CS1, the attrition rate. And in this case, attrition rate means a rate at which a group does not take the next course in a sequence within 4 semesters that they took the original course. So in this case, a student taking non-engineering CS1 in fall of 2014, they would have counted as attrited if they did not take CS2 within 4 semesters of fall 2013. We can see here that there is a difference between the men and the women's attrition rate. And this is similar in the CS2 attrition rate as well. We also see this in the other CS1 course and in our discrete math course. And here, the means are differing by much more than in the withdrawal rate, as much as 14.6%. We also notice that as we keep moving through, we see that not only does the attrition rate decrease, but the difference between the attrition rate of men and women dissipates. So we see that in CS3, there is no significant difference between the male and the women attrition rate. So women, despite passing, are not moving on to the next course in the sequence. We see this for almost all of our courses leading up to CS3. And we see large differences in the means here, as much as 14.6%. And we also see that once students reach CS3, regardless of gender, we're going to move on to the upper level courses. So this begs the question, why are women choosing not to go on, particularly in the courses before CS3, since that seems to be where there's the most differences between men and women? So we ask the question of, are they receiving the same grades? This tends to be a large decision, or a large factor in the decision to move on to the next course of what grade you received in the original course. So we see here a histogram of grades received in CS2. And we see that the women's curve is shifted to the right of the men's curve. So this means that women are receiving lower grades in this course. And this is similar in engineering CS1, CS2 as pictured here, discrete math, and CS3. And this is almost all of the courses in our sequence. What's even more interesting is the cumulative GPA of all CS students, which is what this graph shows. This graph splits up cumulative GPA over time between the 4 groups of students that we have. So it splits between the arts and sciences school and the engineering school, and by gender. And we see that the women groups have the same or higher cumulative GPA than the male groups. So this is very interesting because as we compare it to the CS graphs, where women are receiving lower grades consistently throughout the program. So we see in almost all of our courses, women are receiving lower grades than men, but they have equally high GPAs as engineering men and higher GPAs than non-engineering men. So this tells us that women are performing just as well, if not better, in our non-CS courses. And some of those are also very technical courses, especially for those engineering women. The School of Engineering requires many technical courses, such as physics and high-level maths, that they seem to be performing just as well in. So we think this is a specific problem with CS and not just technical courses in general. So we ask, why are women receiving lower grades in these courses but not others? We also want to look at what else could possibly be affecting the attrition rate. So we see that grades are definitely the highest factor, and this table is an analysis of variance tests between grades received in discrete math and CS2 and gender. And in this analysis, each of the factors are independent of each other. So we see that grades are the largest factor in the student's decision to move on. Both CS2 and discrete math grades have a large factor in the student's decision. However, even after controlling for grades, we see that gender still plays a role, and this is totally independent of grades. So this means if 2 students a male and a female, were to receive the same grade in CS2, the man would still be more likely to move on to CS3. So this is completely independent of their grade received, and it's only a factor of their gender alone. So what this means is that even if we eliminate the grade disparity, the gender balance would definitely be improved, but it would not bring it to equality, because we still see this outside factor of gender independent of grades. So we think that we should be focusing on this grade disparity, but there's still more work to be done. So let's just wrap all this up and review everything we've talked about and talk about what we would like to explore in the future. So despite a large increase in women, we still see a lack of women continuing through the program, even though in one of our CS1 courses we saw about 42% women. By the end, there's only 20% women. We saw a gender disparity in attrition rates, meaning the rate at which students are choosing to move on, in CS1, CS2, and discrete math, so it's all the courses before CS3. We also saw that there are other factors, other than grades, that affect a student's decision to move on. So, all of this, we want to ask the following questions for the future. Number 1 is we want to ask, why is there a grade imbalance in some classes but not others? In the non-engineering CS1 course, there was no grade imbalance, but in all the other courses, there were. So what is that course doing differently? And how can we apply it to the other classes? We also only looked at gender and grades as factors of a student's decision to move on. We want to explore some other things. What other factors could possibly contribute to this decision? And why specifically gender, independent of anything else, is a contributing factor in a student's decision to move on. We also would love to get rid of this factor in a student's decision so that we can achieve gender balance. We would love to see this study duplicated at other institutions. This will help solidify our work and gives everybody else a great view of what your program gender balance really looks like. So I would like to thank you for tuning in under these unusual circumstances, and I hope that you all are staying safe and healthy. If you have any questions, please feel free to reach out to me. You can email me at amyjbaer@umich.edu. Thank you so much, and I hope you have a wonderful day.